location analytics is a very deep area. I'm barely scratching the surface here, but assuming you have like 3 data points, and if you know that this is Air Canada Center, right? So you see this data point, it's called pointing polygon, so you can probably infer that this user has gone to Air Canada Center. But at the meantime, if you can get some data from Air Canada Center or some of the event website, you know that, last Thursday there's a Miley Cyrus concert, between 7 and 10. So you can probably infer that this user, he's probably a teenager, he's interested in Miley Cyrus. Single data point probably won't tell you a lot about the user. Sometimes accuracy is not very high. But if you have some repeated pattern about this user, sometimes you can be pretty accurate about your prediction. But again, switching scenario, if this is Eaton Center, right? This is the user location, but these are all like points of interest. So you have Subway, there are clothing shops, and there are also gift shops, coffee shops. In this kind of scenario, it's really hard to tell what the user is doing there. But there are also ways you can do that, probably at a lower level of accuracy. But again, you can also build models to infer that. With wearables and also some exciting technologies that Kevin's going to talk about today, like Internet of Things, the way we actually collect data is also different. So you have beacons collecting data at much granular level. So the way you apply location analytics will also change in the future. So this is about location. And also let's talk about how we can actually classify a news article. So based on the 500 news you read, can I infer something about your interest? So obviously the first step is to collect data. These are all the news articles you scrape or you read from other APIs and you show in your app. There are a lot of useful textual data you can actually extract. This is your application, so the title, author, what type of magazine, and the most importantly, the content of the news. And then you can do feature extraction if you understand machine learning. So you can extract topic, entity recognition, some simple approach such as bag of words, and you extract a lot of features, and then eventually you can feed that into machine learning algorithm, such as neural network. And then in the end, you're probably getting something like, I'm 95% confident that this is a technology related, 10% about fashion. So you can decide whether to classify this piece of news into 2 different categories, because sometimes one news can talk about many different things, not necessarily always about technology. So this is a very simple way to do topic classification. There are this is pretty hot research topic in the last few years. So there are different kinds of ways to do this. But from industry perspective, there are obviously more complex way you can do the analysis, but to apply that in reality, sometimes most people tend to go with simple models. Right? Yes.
你在谈到那个理由的时候，你是分析每一个 word 是吧？就是这个 use 里头分析
每一个 word 都是你的那个 model 里面的 feature， 对。但它不光是 word， 比如说 word 的话有 bag of words， 你可能知道比如说在这个新闻里面 NBA 这个词出现了很多次，可能你就会说这可能跟篮球有关。但是有的时候你可能会用比如说 topic extraction， 你可能会知道这不光它可能提到了 NBA， 但可能它这个更有可能是谈论Michael Jordan's wife。 Right? Obviously, it's still going to mention NBA， 但它可能因为你如果用其他的方法，你可能得到它这个主题可能跟 celebrity 相关，所以它也牵涉到篮球这样。
是你是把这些 wording 里头拿来放进以后，然后再分析这个 wording 里头的出现的这个频率。
对，你可以用 TF-IDF 那样的基础，但现在那个是比较基本的方法，但可能有更好的方法来做这些 text analysis， 那只是可能方法的一种。But that would be a starting point. You always start from analyzing the word.
你们在分类的时候，这个朋友
我们待会儿 Q&A 的时候，或者我们可以单独讲。All right. So what we've talked about is, you have a piece of news. We would like to understand what that news is about. We have location data. I want to know where you've been. But then over time, we know where you've been. We know what news you read, so I know a lot of information about the user. So let's put all of these data and insight on a timeline, right? So this is about myself. I bought my first house in 2013. So let's say if I go to this, this app and I go to this website a lot, so you can probably infer that he's hunting for a house. In 2014, probably, I'm going to baby center app more and more. Because I settled down, I'm planning for a baby. Eventually the baby arrived. I'm shopping for, diapers. About a month ago, or it should be like 3-4 months ago, I'm looking for new jobs. So I went to LinkedIn more often. About a week ago, I'm reading some news article because I'm using Cassandra right now, doing some graph analytics. About an hour ago, this is what I had for lunch. And just about a minute ago, I was in this location, right? So there are a lot of things you can tell about this user. We can zoom in a little bit. So this is like at year, month level. But if you zoom in a little bit, you will see that this is some signal that's repeatedly observed. So like I read news every day, so you can tell this is a stable taste signal. So he's probably very interested in, he has a good habit of reading news. But there are also some signals, for example, maybe I only do shopping for my wife last December because it's her birthday. I'm shopping for some gift, but it only occurs once in a while. And there are some behavior that observed in the past, but we haven't observed them quite often in the last few months. Again, there are different types of taste signal. And if you're doing something, maybe searching for a house more intensively in the last few days, this is also a different type of taste signal. So you can actually target this user based on this kind of pattern. You can even zoom in at the day level, so do some kind of sessionization, because if you're at work, you probably read a lot of news and finance related. If your work is not very busy and you want to kill time, but maybe at home you're more likely to read sports related news. So we can do things at this granularity, but again, the data is massive. If you want to do this kind of analysis for each individual user, and if you have 240 million users, obviously a traditional solution such as SaaS is not going to cut it, right? In the end, this is our final data product, right? We're trying to adopt a graph-based approach, but on this graph, you have this user's taste graph about sports, hockey. This is actually a macro level view, so you have millions of users. They give you all kinds of taste signals. So it's almost like building a recommendation engine. But you know that people who actually read sports-related news, they also tend to read basketball. People who read about basketball are also interested in reading LeBron James. So without even tapping into a knowledge graph such as Google Knowledge Graph or Wikipedia, if you have enough data, you can build something like this, right? And then in the end, you end up having some personal level taste graph. This is, for example, user A's taste graph, and this is user B's taste profile. So they have totally different tastes.